And that's really good, obviously, for this because our panelists can be larger on your screen while they talk, just in case you haven't actually done that yet. Cool.
Thank you for that. That does help quite a bit. All right. Excellent. So yeah, if there are questions, you can use the Slack or you can raise your hand here. But I just wanted to kick it off. We brainstormed some topics beforehand. So one question that people had was how do you decide when to develop something new versus use something that exists already? So Néstor, do you want to take
Sure.
take the first stab at that?
Yeah,
Yeah, go ahead.
Oh, go ahead. Yeah, I've learned a lot about that question here at STScI in particular. And I think over the years, I've gained experience in that it has to match 4 dimensions in my mind if you want to start something new. It's timing, flexibility, accessibility, and expandability, which are I think the key things. Timing is important because when you make something new, it has the maximum impact whenever there's something, the new mission coming or new data coming that it's relevant to the thing that you're developing, for instance. In terms of flexibility, I think it's important that your tool is multi-purpose, for instance. If you can see multiple purposes aside from your own science, that's super, super impactful as well for your tools and for deciding if to make something new or use something from the past. I think the key point that I've seen a lot in the new kind of codes of waves of codes, like Orbitize included, stuff like Exoplanet and so on, it's accessibility in terms of making your code accessible or having different levels of example use cases, such that if you see that other codes are not providing lower bars, you can be the entry level. And then that provides something new because it extends the user base. That's something that is super, super important too for designing if you want to go into doing a new thing. And in terms of expandability, it's the capability of your code base to be expanded into new directions. Like if you're writing a code to do a transit fitting, why can it be expandable to do eclipses or phase curves and so on? So if you can expand on your code, then that speaks of writing something new, I guess. If you see that no other code is doing something similar. Those are the 4 dimensions that I can think of when how to define if you should go for something new. Or just reuse previous code.
Yeah, thank you for that, Néstor. That's a very thorough answer, much more thorough than I was going to give. I think I might have jumped the gun a little bit. Maybe we should introduce our panel first. So, I'm Jason Eastman. I am at the CFA. I am the author of ExoFast and ExoFast V2. Which is a global modeling package for transits, radial velocities, astrometry, and it models the star as well with an SED and a evolutionary model. So that's where I'm coming from, and I've also written timing packages that calculate the barycentric velocity or barycentric Julian date and the barycentric velocity correction. And I think that's most of my open source packages. Sarah, is there anything else you want to add that you didn't cover in your talk?
Well, thank you. You know me at this point.
Okay. Alice, do you want to introduce yourself?
Sure. I'm Alice Allen. I'm the editor of the Astrophysics Source Code Library, which is a registry of software used in astronomy research. We also house codes when we're asked to, and the ASCL actually started as a repository, but now we mostly point to where software is because there's so many good places to put it now. So I started my my career, my academic background is in biology, but when I left school, I started working as a programmer, and I programmed for a while and then got into various other things. And now I'm retired from my day job and I do astronomy for fun. And I'm at the University of Maryland now. So, and happy to be here. Thanks for asking me.
All right. Néstor, do you want to introduce yourself?
Sure. Hi, everyone. I'm an astronomer at the Space Telescope Science Institute. I lead the Juliet package, which is also a global modeling tool for transits, radial velocities, now doing secondary eclipses even. And I'm the science lead here at STScI of the ExoCDK package. If you wrote your UST proposals, you probably know ExoCDK. So that's me. Yeah, I'm also an astronomer by day job.
All right, thanks. And Thomas?
Yeah. Hi, everyone. Yeah, I'm Thomas Fauchez. I'm at Goddard, and I'm the co-lead of the Cuisine project, which is a framework to host model intercomparison for exoplanets. So I'm really dealing with a lot of different models, a lot of different data. And so, yeah, I'm very interested in that topic.
All right. So we have a couple of questions. So just as a reminder, there's some of the questions are coming in the discuss talks. If we can move that over to the discuss panel, best practices talks, that'd be great. But first question is for Sarah. Basically, this might start a fight about IDL versus Python, but they're asking about why not publish the IDL code with documentation as opposed to rewrite it in Python? Just because IDL is proprietary doesn't mean that that it doesn't have to be open source.
Yeah, that's a really great point, and it was not what I meant to imply, that like IDL is not open sourceable and Python is. There are a bunch of reasons that we didn't want to open source the original code, none of which were that it was in IDL. Basically, it just was built off of some other proprietary code, and we wanted to rewrite the code based off of a non-proprietary, is the Kepler solver, I think, that was proprietary in particular. And Jason's MCMC code was also, written in Python, and so we figured it would be easier to build the package up from scratch in Python. Another reason that we decided to go for Python rather than IDL was that we found it easier to write object-oriented code in Python, and that was a big part of the initial design of Orbitize. Again, not to say that you absolutely can't write object-oriented code in IDL. It just was sort of easier. So it was a decision rather than like, oh, IDL is bad and Python is good. Yeah, but yeah, you can and absolutely should open source IDL code as well.
So as Exofast is in IDL, I will also reiterate that yes, you can write open source software in IDL, and many people might not be aware, but you can actually pre-compile the IDL and run it for free, which Exofast can do. So and it's not that hard. There are a few limitations, but it's not that hard to set that up. And if you have questions about how to do that, feel free to email me. Any other comments about IDL versus Python without devolving too much? All right. Let's see. So a question from Aviv is he's concerned that we rely too heavily on commercial partners like GitHub. So what would happen if GitHub went belly up? And I have to admit that I have nightmares about, like, I don't back up my code very well that's not on GitHub. And so if GitHub disappeared and all of my code disappeared, I would be scrambling. I think it's definitely worth thinking harder about that, because there is no there's nothing that like if they go belly up, you're out of luck. So yeah, Néstor, do you want to comment too?
Alice, raise your hand first. Let's go with Alice.
I thought you had your hand raised first, but I will talk about this a little bit. So I worry about this too, and we have seen this happen already with Google code closing and with Mercurial support being dropped by Bitbucket, and that caused the loss of a lot of codes. So there are different things that you can do. And of course there's Zenodo, which is that's kind of a community resource. So that's one place to put your software for the long term. I would suggest putting it in multiple places. I'll tell you, we download all of the code that we register, and we have given people their code back when their site has disappeared because they have it on an institutional website, or the server breaks, or something happens, like Bitbucket dropping Mercurial support. We gave several people their code back because we happen to have a copy of it. GitHub is backed up by Software Heritage, I don't know how many of you are aware of Software Heritage, but it's a large project in Europe, in France specifically, and it has ingested all of GitHub. All of GitHub. So it's a very big project. I push stuff when we register stuff, and you've created a very nice web page for your software. I push that to archive, to the Wayback Machine. So there are things that you can do to help preserve it, but I also have nightmares about Microsoft saying, hey, we're not going to support free GitHub anymore, or, you know, I think they'd probably keep the paid part for as long as they get money out of it. But yes, I worry about that too, and you're wise to worry about that.
Can you expand a little bit on pushing to the archive, the Wayback Machine? Because I thought that was just automatic. I didn't know you need to explicitly do that.
Well, it doesn't index everything, right? So if you want to make sure that your stuff is indexed, you can actually add it to the Wayback Machine. There is a widget that you can put on your taskbar, which is what I do. I've got a Wayback push. And when I'm looking at your page, I click that button and it takes care of archiving that URL. So there are lots of code sites that it did not have until we started pushing them. And I'm sure we've missed many. So if you have a website, I don't do that for GitHub repos. I do it for web pages or other resources that aren't in like GitHub or Bitbucket, SourceForge, etc. Because I know that I can download the whole package, and I do. So I've got your GitHub repo, you know, as a zip file somewhere. And I also know that Software Heritage is downloading the GitHub site. So I know that there are at least 2 places where that exists, and probably others if they've cloned your site. But your web pages, I push them to, like I said, so there's a widget that you can get on the Wayback Machine, on the archive service, and add that so you can push pages that you want saved to archive, to that archive.
Can you link to that widget in the Slack at some point? Maybe not now, but
I don't know if I can actually link to the, well, maybe I can, but I'll see what I can do. Let's see, Wayback save.
Thank you. Any other comments on commercial options disappearing from our panelists? All right. So
Definitely
one
haven't thought
other
about
comment
that.
that I missed. Sorry, go ahead.
Sorry. I was just going to say I would also be in a very big pickle if GitHub went belly up. So I was taking notes as you were talking.
Yeah, so it sounds good that GitHub is relatively secure, but there are certainly
what Alice was mentioning is what big missions do. Like we use like GitLab, for instance. We have our own instance of GitLab too, and I think spreading it's much better than just relying on one. In any case, I think, you know, the popularity of GitHub is also because they have a business model that provides flexibility for everyone to use, and the bar of use it's very, very low. Same thing I was mentioning before. So there's a reason why the community is relying so much on these resources. Like CDS don't have this, universities don't have this, and the expected value of CDS or the universities breaking too is the same as GitHub, perhaps even larger, I would say, given how well their business goes. So yeah, distributing is the best.
Right, and there I see there's a question about Zenodo. So Zenodo is a good option also, but there have been things like Zenodo, such as Figshare, where you load your stuff onto Figshare or some of these others, and then they turn into and they're free for many years, and then they attach some kind of pay, right? So there you have to. So I encourage people, push your code to Zenodo, push your code to some of these sites where you keep it. Your institution probably has a repository for your scientific artifacts. Push your code there too. But at some point, one or more of these is going to disappear because nothing lasts forever in the digital world. So except like the bad stuff that you did when you were a teenager that you've now had to bury when people Google your name or something, you know. So I'm not speaking from experience or anything, but you know, so yeah, that's so Zenodo is very good. One of the issues with Zenodo right now is that people push there. You can set up GitHub to automatically push to Zenodo when you have a new version, which is great, but there's now an issue with ADS having many multiple records for the same artifact, and that can come from a paper describing it, the Zenodo, a whole bunch of different Zenodo DOIs, the ASCL indexing it, and all of that. So that's on my to-do list now is to set up a meeting with various players because we've been talking about this proliferation issue. So, you know, when you push to Zenodo, be mindful about it and make sure that you really need to push that particular version and mint the DOI for it. And that's what you want people to cite. Yeah, I mean, you want that artifact is what you want them to use, that particular artifact.
So part of my workflow is just like I don't really think that much to even push just to GitHub. So adding all these other layers of redundancy is very far from my usual workflow. Is there something like you said you can automatically link that to Zenodo? Are there other tools like that you can automatically set this up once and then forget about it and it's automatically pushed to these mini repositories?
I don't know of others. Arvon set that up. He was working for GitHub at the time, and was, you know, he's the one who set that up. But I don't know of others. There are other tools that work around software for other purposes, such as getting a metadata file that describes how you want your software cited. So there are a couple of those. Citation.cff right now has a Ruby gem that you can, through GitHub, you can get a citation.cff file to put on your code repo that says how you want your code cited. And I know that there's another metadata format called CodeMeta, which includes more information. It's not just restricted to citation. And somebody's working on that Ruby gem, and that should be out within the next couple of months, also on GitHub. So GitHub will be providing that kind of support too for CodeMeta as it does for citation.cff. All
right, I think we've talked about that a lot. There's a lot of things to discuss here, so let's move on. Thanks for that great question. That was very useful. So Avi says, I wanted to hear the panelists' perspective on how we improve the process culture around inner code comparisons for foundational algorithms. Everyone obviously says comparison is always good, but frankly, comparison is incredibly time-consuming, requires buy-in from multiple developers, and really doesn't get much credit in the broader research world. Thoughts? So,
Yeah,
Thomas, do you want to kick us
sure.
off there?
Sure, absolutely. Yeah, I think, I mean, Néstor said it earlier, and there is a massive difference between availability and accessibility. It's true that intercomparison are extremely time consuming, but even in terms of data, when we make the data to be shared to the community, they need to be post-processed. We need to first agree on a certain, format, and they need to be easily accessible for everyone, and that you can use it without having to do yourself some post-processing. So it's something we have learned with different intercomparison we have done in the Cuisine project, that the best way to optimize everyone time is like people that knows really well a certain code. They know how to post-process the data. They know, what would be the final product. And if each code, each programmer for different code do that, then you will limit drastically the time you spend doing the intercomparison, and more focusing, on comparing the data themselves.
Yeah, I totally agree with that sentiment about standardization is key. I think, especially if we could standardize the inputs, then I think we could help standardize the outputs too. and Néstor and I have talked about doing exactly that sort of comparison. If we could develop a standard input between Juliet and Exofast, we could do some wholesale cross comparisons that would be extremely valuable. And we've talked about that off and on for several years and never gotten around to it because it is so incredibly time consuming and so poorly rewarded that I'm not sure it'll ever get done. But I do think it's immensely valuable to the community to do these sorts of tests, and it's unfortunate that we can't do it.
Yeah, and metadata are crucial for that. Like, you know, if you have a good amount of metadata describing all your variables, what are the acronyms, and if you can follow a certain convention, I know that in Earth Science they have the CF convention. That's really helpful as well. But yeah, metadata are crucial for that.
Yeah, we can't even agree on the definition of omega. So
right, yeah.
Sarah, go ahead.
Yeah, I was going to say, I think data challenges are a really good way to facilitate this as well. But I definitely agree that there sort of needs to be a fundamental change to the way that we credit people doing this work. We need to make sure that people who are doing code comparison get, like, you know, publications out of it or whatever is the sort of standard way of giving credit in astronomy. But that said, I've seen some really cool data challenges, like people generating, like, you know, an active star data set and having people with RV activity modeling codes, just like letting their codes loose and trying to figure out the activity in the system, and then all publishing the results of that. So I think more funding from the community for exercises like that and more credit for the people that are doing those types of things is really important. Yeah, and I agree with everything everyone else said too.
All right, any other comments from our panel? Great question, Avi. Okay, so let's move on to coding standards or style guidelines or unit tests or any comments from our panel about should we sort of coalesce on coding standards to make this open source easier, or does that just put more onus on the open source developers and make it prohibitive to contribute?
I have a couple thoughts about this. One is that I think as a community, we can rely more on automated checks. So like with style, for example, like if you want your Python code to be compliant with PEP 8, which is the standard, you know, style guidelines for Python, most of that is automatic. You can just run a script on your code to do that. And so that doesn't take very much extra time. So I think starting to do things like that and incorporating that into our practice of contributing code would be really helpful for the community. I was going to say something else.
So to interrupt you there, so I'm not a huge Python person, as many people will probably frustratingly know. So I'm not that familiar with PEP 8 or style guidelines for Python, and my Python code is probably terrible. Is that tool that you mentioned, does it automatically fix your code into PEP 8 or just tell you about all the lines that are terrible?
Yeah, so I don't have a specific tool in mind. I know that there are tools out there that will do both. There are some that will actually fix your code, and there are some that'll just say this is not consistent with style. But yeah, definitely curious to get other people's thoughts about if there are any tools like that. I guess I was just bringing it up to say that, like, I think these are some tools that we as a community could start seeking out or writing ourselves, I guess.
Yeah, great. Alice?
Yeah, I would say that you need to educate people about some of these tools. So that would be an incredibly helpful AAS session, for example. Here are tools that, and you know, there are ways to disseminate information about that, but putting things right on your GitHub repo saying we use these tools to do these things could be helpful as well, because people look at your GitHub repo, whereas they may not go to the AAS session, right? So educating people on what these tools are and where they can find them would be really helpful. Maybe we can talk about how to do some of that afterwards.
Yeah, that's great. Let's see, so that kind of brought me up to a question that I wanted to ask Sarah. Oh, sorry. Do you want to interject, Néstor?
I just wanted to mention that this is also related to, people sometimes ask, well, why people are not contributing to my code from the community, right? You have to remember that, your code base is your workplace, so to speak, to the contributors. So if your code is messy and, all the lines are everywhere and there's not a clear path in your code to structure your code, and that starts with PEP 8. I mean, software engineers in particular, I work with a ton of them here at STScI, and they go bonkers if you don't use PEP 8, right? So having a clean code actually helps a lot in that. It makes it easier to point people to, like, I want to add X, and then you have a structure which is mentioned, like, this particular function is what you're looking for. If everything's messy or there's repetitiveness in your code, then that gets very, very, very messy. So it's also important to get people working with you to have nice standards set up within your code. And the software engineering side of things in in industry and beyond, they have done this to death, and for a reason, for this very same reason. So it's important to be educated. I echo what Alice and Sarah have been saying.
Yeah, so that transition to a question that I wanted to ask Sarah during her talk is you had hinted that Orbitize would be a lot less work because you wouldn't have to answer all these support emails, and then you said it wasn't, but it was better, and I can certainly relate to that, being the author of Exofast too. That the better you make it, the more queries you get. But can you elaborate on the trade-offs you saw between the extra work that it made and why you felt that was worthwhile?
Yeah, absolutely. Thanks for bringing that up. I think primarily it was more work just because more people were using it and it had more influence. So, it was, I think the like normalized work, like work per unit output, was probably less, but the absolute amount of work was greater just because there were more projects that it was being applied to. The type of work changed from like being so when Eric and I were responding to individual queries to use the code, we were both maintaining the code, so like looking for bugs and fixing bugs when they came up and improving the code, adding new features. We were also using the code, so every time someone wanted to run an orbit fit, we would have to run it ourselves, and these are often very long fits, so they could take a couple days to run on a cluster. And then also coordinating with people, so writing emails and making plots for people and all that kind of stuff. So making the code open source took a lot of the onus off of like actually doing the work for other people. But the work changed to I still maintain the code, I still respond to bugs and feature requests and things like that. And then people also will ask questions about particular things that they're running into with their fits. I usually try to, if I get the same question a couple times, I will, put it in an FAQ on the website, and so I can just point people there. So that also reduces the work, just sort of making resources that people can go to. But yeah, it's different. Does that answer the question?
Yeah, Néstor, do you wanna?
Yeah, one thing I remember when I started with Juliet that helped a lot was like, and this will serve to those of you folks like starting with your own scripts or your own codes that you're putting public, is to have some sort of like Juliet ambassadors. And the way I did this was like, whenever I had the opportunity to go to a workshop, I was like, can I give like a small talk on how to use Juliet, like just simple examples? And then people will get really excited because they can use, people raise their hand like, I can use this for stellar rotational variability, right? I don't even like planets. Like, yes, you can do this, so you can speak to your community, right? So you will spend time with them, training them, and they will go to these other communities and you spread the word. So dividing and conquer sometimes is also the answer to not getting too many requests yourself to like implement new stuff, or does this work for this other science case? Let the users to discover it, and the way to do it again, I think, is to reaching out to that community directly. I don't expect like you put it in pip and it's pip installable, you have great documentation and that's it, like my work is done, and then you go away. So going to the community and speaking with them, it's super, super important, and really relieves the load, because you have your local Juliet experts by now, right, around the world. in my case.
Yeah, I would totally agree with that. I have Joey Rodriguez is my biggest ambassador who uses Exofast 2 a lot. So, any other comments from Thomas or Alice? All right. So, sort of on that same line, how do you balance the documentation, like how painful it is to write documentation, and how useful it is to have that documentation for those users? Anyone want to take that on?
Yeah, I can comment. I spend a lot of time writing documentation, and especially before new big releases of the code, I'll go through and like read through all of my documentation, which takes a really, really long time, and it's very annoying to do. Like, I'm always glad that I did it, but I never want to do it. I think I always think of it like, this is going to take me a lot of time in the short term, but it's going to save me time in the long term. It's going to save me answering questions over email or people being confused. And so it's an investment in the code's usability in the long term. I definitely don't like doing it as much as I like coding or debugging, but it's important. There are parts of documentation that I do like writing, like I really like writing tutorials. I think that's really fun. So I tend to lean into that a lot and, spend time writing really, really good tutorials, and, linking within the documentation to tutorials. So I guess if there are parts that you like, lean into that for sure. And yeah, just push through the parts that are annoying because it's an investment.
Let's go to Thomas first.
Yeah. Yeah, in addition to the documentation, I mean, being able to comment directly inside the code also is extremely useful, because sometimes it's very difficult when you receive the code that you have not developed and the code is not really commented. So when I'm coding, I'm really make this extra effort to systematically comment most of the lines, to make it, more easier even for myself. If I want to come back on my code in a few years, I remember what is what, and also much more easier to share the code to other people after.
Thank you. Yeah, Néstor.
Related to what Thomas just said, there's standards, especially in particular in Python, these Python docstrings, that are particularly important. And I work with software engineers. They love them. Like, whenever you write those strings, they will like hug you, literally. So the thing to do, I think, is while you're writing a function, really take the time, like after you finish writing your fabulous function that does your plots in purple, as Sarah likes, you write, your docstring right away, because that's where you really understand what the code is doing. And there's a Python docstring format that then it's very easy to link with your documentation and read the docs. So you can just call it. So, taking the time to document inline with docstrings, and also, little comments along the code, it's the way to go too. So you don't have to do it later. So you're, Néstor from the future always, says thank you to Néstor from the past for doing that.
Yes, that is very, very true. The one thing that I find very frustrating about documentation is when you make a change to the code, then you have to make the change to the documentation too, and it's hard to keep that up to date. And sometimes sometimes you have very, very misleading documentation because you did it all in one spurt, and then you've changed the code underneath it, and then you have to go back. And so I think a lot of the Exofast 2 documentation is that way. But that's just another gotcha that makes it frustrating, but it's still very important. All right, any other comments on that? Okay, I want to change, but yeah, go ahead.
I'd just add that when I'm writing new code and just trying to get it to work and work correctly, I usually won't format my documentation in the final way. Like, I'll just sort of make notes for myself, like, this is what this variable means and stuff like that. And then when I'm gonna, push the code, I'll go back and format it and make it look nice. So I think that's fine. I don't think you have to write, perfect, beautiful doc strings every time you're writing a line of code.
So I want to change gears a little bit, because we're talking about all these best practices, but I also want to understand the flip side of people who may not adhere to these best practices, but still write useful code. And I want to sort of encourage those people not to be intimidated by writing unit tests and writing perfect documentation and having code that's in PEP 8 and all that stuff. So how do you encourage someone who's new to code or new to coding standards and just sort of is the typical astronomer who's writing code that works barely to still put that on GitHub and make that available to the community? So Sarah, you want to take that?
Yeah, I have a couple thoughts. So first, I would say don't be embarrassed. Like any code is better than no code, and putting it online is better than not putting it online. Even if it's like terrible code in your mind, I think still do it. The other thing I would say is that a lot of these practices are not difficult. They're just time. So like documenting your code and testing your code. Especially with unit tests, I think the easiest way to write unit tests is just to keep all of the code that you write to test your code. Most astronomers, I think, already test their code. They'll as they're running a function for the first time, they'll print out did it work or did you get here, or print out a value and just check that value is correct. So all unit tests is just taking that and making it into a function that you can run every time you make a change to your code. So I think even if when you're testing your code, you just keep a list of all of the things that you tried or checked, and then go back later and just formalize those and make those into separate functions. I think that's all you need to do basically. And it's very helpful to have those sorts of tests because you'll immediately know when you make a change to your code and something breaks because of the unit tests that you have.
Great. Any other comments?
Well, I really like the one is, bad code or any code is better than no code. And that's, if you've used it in research, it should be released because your research depends on it and transparency and blah, 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 all of that. So yes, don't be embarrassed by your code. First of all, everybody's code has bugs, and that's just a lot of commercial code has bugs. Don't we know that? And those are, people paid to write software. And so yeah, don't be embarrassed by it. No matter how bad your code you think your code is, I have written code that's much worse. So that's so yes, make it available. Put it out there.
And I will also say, the process of documenting and even just the process of making it public has forced me to think through things and identify some pretty severe bugs in some cases that I would not have identified if I were just doing it for myself. I would just be like, it's okay. But when you have to explain to someone else, you do think about it a little deeper, and it is better for it. It takes more time, but it's a better product for it. Yeah, I thought somebody with a hand up. Was that Néstor or Sarah? No?
I'll add one thing, which is that I think of all code that I write as public code, meaning that I don't ever think that I'm coding just for myself, even if I end up being the only person that ever uses it. It's always really helpful to, from the get-go, think of your code as something that's going to be public facing. So that's not to say that I immediately code perfect code. I'll code, to get it to work and to try things out. But I always sort of think that process is going to result in something that other people will see. And that helps. I think that's a helpful mindset to have.
Yeah, and I just to add to that, I think that those other people might be you in 2 years or 3 years. And that has certainly saved my bacon several times when I come back and 2 years ago, Jason was kind to me, or, oh, he was not kind to me.
Yeah, and I never remember, if I think I'm going to remember something about how code works, I won't. I never will. So I'm always glad that I documented.
All right, Avi has, this might be our last question that we have time for, so let's do that. So Avi says, what about any less used best practices for using someone else's open source code? Should we worry about licenses? What about contacting the developer? How should we cite that code if it doesn't have a publication?
I'm happy to weigh in on this.
Yeah, go for it.
So you should always cite code that you use, because other people should be able to see, to know what you used. If there's no way to cite it, for example, if the code comes from another discipline, which sometimes happens, and you're using it and there's no code paper, the author has not suggested how to use it, I mean, how to cite it, all of that. We've had people writing papers submit software to the ASCL simply to get something that is a way to cite it, because you can cite with an ASCL ID. There are other ways to cite code too that are also very good. I'm not plugging the ASCL here, but that is one way to get a citable artifact for it. And I didn't think of that. I learned that other people were doing that when I was seeing submissions from people who didn't write the code. And they were saying in the notes, I'm submitting this so I can cite it because there's no good way to cite it. And I'd go look to see whether that was true. And yeah, there was no good way to cite it. So
interesting. Do they ever contact the developers before they do that, or
I
get their
do.
permission?
No, when we get a submission, if it meets our criteria and we publish it with an ASCL ID, we then write to the developer to say, we've listed your code on the ASCL, here's the link, please check that the entry reads correctly, that it has the right authors, that the description is accurate. So yeah, we do contact developers. Anybody who submits a code or who has a code in the ASCL, we didn't do this at the very beginning when I started working on the ASCL. It took me maybe a year to start doing this, but since like 2011, everybody whose code appears on the ASCL should, after 2011 or 2012, should have gotten an email from somebody at the ASCL saying your code is on the ASCL, please go look at the entry. So yeah, we do write to the developers in that case. And we've even had people take code that isn't on GitHub. They found it somewhere and they put it on GitHub, and then they want to register it in the ASCL, and it's like, I'm not going to link to that GitHub repo unless the developer is okay with that. So yeah, then we do check with the developer before we do anything with that code, because it's somebody's intellectual property has been moved. And yes, you should worry about the licensing too. I mean, code can be copyrighted, but still available to use. So copyright typically goes to using, not necessarily using the code. Like, you can use numerical recipes, but you can't share them, right? So you have the right to copy. Do you have the right to copy the code and put it someplace else? And that's where the license comes in.
So that's a great, I think, final note is should we worry more about licenses, and is there a perfect license for general scientific code, or a, maybe perfect is the wrong word, but a good default for scientific code?
We have a lot of information about licensing in the ASCL blog and on web pages there, mostly from other people. Jake Vanderplas wrote very good licensing, but I will say, so we don't necessarily recommend one, but I will tell you that the most popular one in astronomy is the MIT license. So, I'll just tell you that.
Okay. All right, I think we're at the time. Thank you to all of our panelists, and what a great discussion. Thank you. I think, Avi, do you want to?
Yeah. Thanks so much to everyone, to all of you. That was great. I think we could have, of course, gone on for another half an hour or even more. Of course, both all of you and to everyone else, please keep chatting away in the channels on Slack. I hope you guys will continue the discussion. And then we'll have another panel discussion, of course, nominally a different topic about funding, resources, and things. Of course, we can continue the discussion on other ideas then as well. But we'll take a half an hour break now and come back at 3:30. Thanks, Jason, for a great moderation.